High-speed time domain measurements, practical tips for improvement. Introduction: making accurate high-speed time domain measurements can be challenging, but finding information will help improve one's techniques shouldn't be. Understanding the basics of oscilloscopes and probes is always helpful, but a few extra tricks of the trade and some good old-fashioned common-sense engineering can be employed to help yield quick and accurate results.
نظام القياس في مجال الزمن يستخدم في قياسات الهوائيات ذات النطاق الترددي الفائق الاتساع، مثل قياسات معاملات الكسب ونماذج الإشعاع، ومعامل دقة استقبال الهوائي في أنظمة الاتصالات اللاسلكية، ويستخدم في القياسات حتى 12 جيجا هرتز.
Selecting oscilloscopes and probes. There are hundreds of oscilloscopes available, ranging from very simple portable models to dedicated rack-mount digital storage scopes that can cost hundreds of thousands of dollars. Some high-end probe alone can cost upwards of 10 grand. The variety of probes that accompany these scopes is also quite impressive, including passive, active current measuring, optical, high voltage, and differential types. It is beyond the scope of this article to provide a complete and true description of each and every scope and probe category available. Bandwidth: whether the signal being measured occurs in analog or digital circuit, the scope needs to have enough bandwidth to faithfully reproduce the signal. For analog measurements, the highest frequency being measured will determine the scope bandwidth. Given their simplicity, probes are quite remarkable devices. A probe consists of a probe tip, which contains a parallel RC network, a length of shielded wire and compression network, and ground clip. The probe foremost requirement is to provide a non-invasive interface between the scope and the circuit, disturbing the circuit as little as possible while allowing the scope to render a near-perfect representation of the signal being measured. Calibration: one of the first things that should be done after acquiring a working scope and probe is to calibrate the probe to ensure that its internal RC time constants are matched. Too often this step is skipped and it's seen as unnecessary. Ground clips and high-speed measurements. Their inherent parasitic inductance makes ground clips and practical high-speed measurements mutually exclusive. A schematic representation of scope probe with a ground clip. The probe-LC combination forms a series resonant circuit, and resonant circuits are the basis of oscillators. Reading a probe for high-speed measurements. In order to obtain meaningful scope plots, we need to read the circuit of the ground clip and dismantle the probe. That's right, take that perfectly good probe apart. The first thing to discard is the press and probe tip adapter. Next, unscrew the plastic sleeve, the surround of the probe tip. Next to go is surround clip. Probe capacitance effects. Probe capacitance affects rise time and amplitude measurements. It can also affect the stability of certain devices. The capacitance adds directly to the node capacitance being probed. The added capacitance increases the node time constants, which slow down the rising and falling edges of pulse. For example, if a pulse generator is connected to arbitrary capacitive load where CL is C1. Propagation delay. An easy way to measure propagation delay is to plug the device under the test DUT at its input and output simultaneously. The propagation delay can be readily read from the scope display as the time difference between the two waveforms.
Omron exhibited high-speed CD overlay measurement equipment at Finetech Japan 2008. This technology is intended to be used by manufacturers to inspect the wiring of LCD array substrates and the light and layer deviation of transistors.
非常に高精度な高精細なカメラとかですね、最新のオートフォーカス機構等を使いまして、非常に高速で高精度な装置に仕上がっております。で、高速につきましては、1.1 秒以下というふうに、業界でも非常に、ナンバーワンの速度を達成しております。で
Conclusion: while high-speed testing is not overly complicated, numerous factors must be considered when venturing into a lab to make high-speed time domain measurements: bandwidth, calibration, rise-time measuring, scope, and probe selection. And probe tip and ground lead lengths all play important roles in the quality and integrity of measurements. Employing some of the techniques mentioned here will help speed up the measurement process and improve the overall quality of results.